Hello students, welcome to the GATE Academy. I am Atul Negi, Faculty of Mechanical Engineering, having experience more than 4 years. Okay, so as we all know, we have started the GATEvantage series, and definitely this series will be giving you an extra edge for your preparation. Okay, so I hope your preparation is going on the right track. Okay, and as we all know, the GATE exam, the date of GATE exam is coming closer, right? So there will be some curiosity in the mind of the student, aspirants basically, what to study, what not to study, right? So in this session, we will be discussing some beautiful concept from theory of machine subject. The topic will be the slider crank mechanism, okay? But before starting the session, just stay here and listen some points, because these points are very much important in the last moment. Okay, only few months are left for the examination. Okay, November, December and January. So you should keep January month for the revision purpose only and the test. Okay, don't touch any new topic. Just keep the January month for the revision. Dedicated. The whole January month should be dedicated for the revision purpose only, right? And in the November and December month, you should consolidate whatever you have studied at one place. Again, you have to consolidate each and every important details of the subject at one place. This is very much important, because at the last time you have started your preparation from the starting of the year only. Okay, you have studied different concepts from different sources, but for the revision purpose, all the concepts, all the points, all the formulas should be consolidated at one place, because it will help you in revising. Okay, it will help you in quickly revise the subject. It is very much important. While you are revising the subject, it is very much important that you have all the important things like important formulas, important relations, important points at one place only. That's why, because you will quickly revise the subject, you will quickly revise. But if the concept, different topics, different contents are available at different sources, so it will take more time. So mark my words, consolidate each and every important details at one place only. It will help you in revising the subject quickly. Okay, so in the month of November and December, you should be focusing on the concepts and the important concepts which are frequently asked in the GATE examination. And one more thing, you should retain whatever you have studied. Don't try to touch new topics. Okay, just retain whatever you have studied. This is one of the most important thing that many of the students forget. Retain whatever you have studied. This is the most important thing, right? So if you consider all these things, it will give you an extra edge while preparing. Okay, this is some basic details you should keep in your mind also. Okay, so we will start the session. We will start the session with the topic slider crank mechanism, and this particular topic you all know. This is all about the mechanism, how the different links move with respect to each other. Why I have selected this particular topic? Because in solving the questions related to slider crank mechanisms, related to any mechanisms, I am talking about a slider crank mechanism because it is one of the most important topic in the GATE, right? But in the mechanism part, students find difficulty in visualizing the concept, because they don't visualize how the mechanism works, how the different elements move with respect to each other. So don't worry, for that I will be using some beautiful animations, and from that animation your visualization problem will be cleared. Okay, so I will be starting the session, right? So before going to details of the slider crank mechanisms, we will be just looking into the details. What is mechanism? Just a basic part, recapitulation only. Okay, what is mechanism? If I ask you what is mechanism, can you tell what is mechanism? In short, how can you define what is mechanism? Okay, you just in short you can briefly answer what is mechanism, because it is very much important. You should have some basic idea with regards to mechanism. Then only we can go into details of any further application part of the mechanism, right? So if I talk about the mechanism, it is nothing but a system, or we can say device, which will transform the motion which will just transform the motion into desired pattern of motion. Again, which will transform, it is a system or any device which will transform what? Motion into desired pattern of motion. What it means? You are giving some input motion, you are giving some input motion to a system, and that system is transforming that particular motion into some desired pattern of motion. Okay, the sole purpose of the mechanism is to get the desired pattern of motion, right? Yeah, correct, Abhishek, yes, absolutely correct. But what is the sole purpose? What is the purpose of that mechanism? To get the desired pattern of motion, right? Your definition is exactly correct. But what is the purpose? Purpose is to get the desired pattern of motion. Okay, and you already know you will be giving some input motion, and input motion is get transformed into some desired pattern of motion, right? But important thing is that when we discuss machine and mechanism, students find difficulty. It looks almost same. What is the difference between machine and mechanism? Can you tell what is the difference between machine and mechanism? Very basic thing. So when we are discussing about the mechanism, we are totally concerned about the motion only. Definitely there will be forces involved in the mechanism, but we are not talking about the mechanism. We are not talking about the forces that are involved in the mechanism, right? We are just concerned about the motion only. It means while you are designing mechanism, the predominant idea is of achieving the desired motion only. We are not concerned with the involved forces. Forces will be there, definitely. Forces will be there. How the motion can happen without force? That's not possible, na? So forces will be there, but we are not concerned with that. Just the input motion you are giving and whatever output motion you are getting. That's only. We have to focus only input motion and output motion, right? There's some basic details. For example, let's suppose if I use, let's suppose, like this. Let's suppose this is our system, and let's suppose this system is nothing but our mechanism. So you will be giving some input motion, right? And you will be getting what? The output motion. Okay. So this is nothing but the basic part only. But the whole transformation of the motion, the whole transformation of the input motion to output motion will be in the system only. System is transforming the motion, right? So we'll be focusing on the mechanism part involving the forces only, involving the motion only. Okay, right? Now think about it. What kind of mechanism you observe in your daily life? What kind of different mechanisms are there? Na? Definitely you will observe different kind of mechanism in your daily life. The very basic example is what? The umbrella. You push one element of the umbrella and another elements will open it in a different manner. Okay. The windshield wiper of the car. These are the basic mechanism you see in your daily life. The steering of the automobile, steering mechanism of the automobile, right? So these are the basic mechanisms, right? So just have some basic details about the mechanism. It is nothing but a system which is converting input motion to output motion. Transformation will be there in the system only, right? Always think about the motion. Okay, so this is the basic detailing of the mechanism. What is mechanism is all about, right? Now, in our GATE examination, we have to study what? We have to study three types of mechanisms. What are those three mechanisms? See, first one will be what? 4-bar mechanism. Second one will be the single slider crank mechanism, and the third one will be the double slider crank mechanism. These are the three mechanisms which we have to discuss for the GATE point of view only. Okay, from the GATE perspective, I am telling these three mechanisms. These are the very most important topics in the mechanism part: 4-bar, single slider, double slider. 4-bar is a very simple one. Okay, 4-bar is very simple one. Single slider, which we are going to discuss in this particular session, and the third one is the double slider. Okay, so most important, in which the maximum number of question has been asked from this particular topic, single slider, right? So we are going to discuss this particular single slider only. But as far as the mechanism is concerned, you should know some basic detailing. What are the basic detailing? In the 4-bar mechanism, there will be 4 links. Links are nothing but the elements of a mechanism. Mechanism is what? The system only, which is just transforming the motion, right? In that system, there are number of elements. That elements are nothing but the links. Okay. So in 4-bar mechanism, we can say there are 4 links, right? And 4 links are connected with respect to each other links through some joints, right? So in 4-bar mechanism, all the links are connected through what? Turning joint, turning pair. We can say turning pair. All the joints are connected with the pair name as turning pair in 4-bar mechanism. But in single slider crank mechanism, there will be 3 turning pair but 1 sliding pair. But in case of double slider crank mechanism, there will be 2 turning pairs and 2 sliding pairs will be there, right? This is the basic detail you should know about these 3 type of mechanism, right? So we'll be going to detail of the single slider crank mechanism, right? So we'll be moving forward from here. First, we'll be discuss what the single slider crank mechanism, right? Now see, in the single slider crank mechanism, there will be various parts, various links will be there. We'll be discussing each and every link and the purpose of that particular link in the mechanism, right? See, first of all, there will be the what? Cylinder will be there. In the cylinder, there will be slider. The red part is nothing but the slider only, right? Next, there will be what? Connecting rod. There will be a connecting rod, right? Next, there will be a crank. There will be a crank, and the crank will be fixed to a frame, okay? And lastly, these are nothing but the turning pairs. This one, this one, this one. These all are turning pair. And where it is the sliding pair? Sliding pair where? Sliding pair will be here only. The slider is sliding in the cylinder only, right? Let's suppose the cylinder is fixed. Let's suppose cylinder is fixed, right? So this is your single slider crank mechanism. There is the basic overview. The basic overview of the single slider crank mechanism will look like this only, right? Now we have to observe the each and every element, each and every link of this particular mechanism, right? So what I call this particular link as a crank. Can you just tell me what is the condition of any link to be called as what? Crank. Can you tell me? Can you just tell me under what condition any link will be called as crank? Can you tell me just basic condition? What is the condition so that any link will be called as the crank? This is the most basic thing. You should know about this. This is the very basic thing and you should know under what conditions the crank, any link will be called as crank. Just tell me fast. You should know about this basic detail. You should know, right? When I say this is your crank, it means that Abhishek, yes, correct, absolutely. It rotates 360. It is known as, yeah, correct, absolutely. It means that if we are saying this is a crank, it means it has a complete rotation. It has a complete rotation, right? What do you mean by complete rotation? It means it can rotate 360 degree. Complete 360 degree rotation will be there for this particular link, and that's why it is known as what? The crank. When you are saying anything that it is a crank, it will rotate completely. Completely means the 360 degree of rotation. And let's suppose someone is not rotating completely 360, partial rotation will be there. Then what will be the name we can use for that particular link? Can you tell me? If the link is not rotating completely, not completely in the sense what? It is partially rotating. What is the name of the link? What name we can suggest? Can you suggest any name? Just tell me fast, Abhishek. Can you suggest some name, the link which is having a partial rotation only? It is very much important. Actually, we'll be discussing that particular name only in the upcoming slider crank mechanism with Worth or the crank and slotted. The link which is having the partial rotation, crank is having the full rotation. The link which is having the partial rotation will be called as what? Rocker. Exactly correct. Exactly right. The oscillating member or the rocker we can say, right? Exactly. The technical name should be what? The rocker, but in physical interpretation we can say it is oscillating member, right? So observe what? This is the crank, this is the connecting rod, right? This is what? CR. In short, I am writing connecting rod as CR, okay? This is cylinder, and in the cylinder there will be what? A slider. There will be what? a slider, right? See, I have talked about what? The input motion and output motion, right? Let us assume I have given some input motion to the slider. Let us assume I have given the input motion to the slider, and because of that input motion given to the slider, there will be rotation of the crank. Can you observe that thing? Just tell me. If we give the input motion to the slider, there will be rotation of the crank, right? Or I just reverse the scenario. Or we can just reverse the scenario. I am giving a rotation to the crank. I am giving an input motion to the crank. What will happen to the slider? Slider will slide. It will reciprocate or slide in the cylinder only. So just focus on the input motion and the output motion, right? Just focus on the input and the output motion, right? So let's suppose I am giving the input motion to the slider and the crank is having the complete rotation. The mechanism will be called as what? Can you find any application? Can you find any application? Just tell me. There is some application in our mechanical engineering of the system which is having what? The input motion to the slider and the output motion to the crank. Can you tell me the mechanism, the application part of that particular mechanism? Can you name where this particular mechanism will be used? IC engine, right? In the case of IC engine, input motion is given to the slider or the piston, and you will be getting the output motion here, the crank only. So that mechanism will be used in what? In what case? In the IC engines, internal combustion engines, right? But if I reverse the scenario, let's suppose I am giving the input motion to the crank. If I give the input motion to the crank, what will happen? The slider will slide in the cylinder, right? So you will find this particular mechanism in what case? In what device? Reciprocating compressor. In the case of reciprocating compressor, you are giving the crank, the input motion to the crank, and the piston will reciprocate, and because of this reciprocation, compression of the gas will be there. So you will find the application of this mechanism in what? The reciprocating compressors, right? Always focus on the input and output motion. What are you giving the input motion and what are you getting from that particular mechanism? So the sole purpose of the mechanism is to get the desired pattern of motion. We are designing the mechanism so that we get the desired pattern of motion. Okay. Forces will be there, but we are not concerned with the forces. Forces will be there, definitely. Right. So this is the basic detailing of the single slider crank mechanism. I hope this is the basic thing you already know. Right. Just moving forward. Right. Inversions. This is again one of the most important topic in which various examination you will find the questions regarding the inversion of single slider crank mechanism, right? You will find various question in the different examinations with regard to what? Inversion of the single slider crank mechanism. Just you have to remember the names. You have to just remember the names of the various mechanisms, right? First of all, you should tell me what is the inversion. What is the inversion meaning? What do you mean by inversion of a mechanism? What do you mean by the inversion of mechanism, right? So if I talk about the inversion of mechanism, it means that just first tell me how you get the mechanism from a kinematic chain. Abhishek has already told us that if the one of the link in the kinematic chain is fixed, we will getting some what? A mechanism. We will get mechanism only when one of the links of a kinematic chain is fixed, right? But let's suppose the chain is having n number of links. Any link can be fixed. Any link can be fixed. No? It is not mandatory that this particular link has to be fixed always. No, it is not like that. Any link can be fixed. If any link can be fixed, so there will be a possibility of n number of mechanisms. Because if we are getting a different mechanism, different mechanism means the different output motion by fixing different links, it means what? We are getting a different mechanism, right? So there are possibilities. What I am saying, the possibilities of mechanisms, the different possibilities of mechanism will be available only when we are fixing different number of links. By fixing different number of links, you are getting the different possibility of mechanisms, right? Why I am saying possibility? Because it may happen if you fix two different links, but you are getting the same output motion. So in that case, in that scenario, we will not saying that we are getting two different mechanisms, because How we can say two different mechanism? Because the output motion is same, so we cannot say we are getting two different mechanism, right? So two different mechanism we can say that two different mechanism only in the case when we are getting different output motion. When we are getting a different output motion, only that case can say we are having a different mechanism, right? That's why I've said there are n number of links, so n number of possibilities are there for the mechanism, right? So this is the basic thing you should know. Now, in the slider crank mechanism, there are 4 links. Remember, there are 4 links, right? See again. First one, this is the cylinder. Second one is what? The slider or piston. Third one is connecting rod, and the fourth one is what? The crank. There are total 4 members, 4 links in the slider crank mechanism. Any link can be fixed, and if the output motion, whatever you are getting from that mechanism is different, then definitely you are getting what? A new mechanism, right? So in this particular case, the cylinder is fixed. In this particular case, cylinder is fixed, right? So you will be getting what? The IC engine, reciprocating compressors, right? But we can fix the crank also, we can fix the connecting rod also, we can fix the slider also. So we'll be getting different mechanism. You just have to remember the names of the mechanism, right? And for the analysis purpose, we'll be using what? The crank and slotted and the Whitworth quick return mechanism, right? So see, first of all, we have fixed the cylinder. Right? Then if we fix the cylinder, then we will be getting what? IC engine and reciprocating compression. Okay, you should remember, when you are fixing the cylinder, you will be getting IC engine and reciprocating compression. Okay, next, if you fix the crank, what you will be getting? See, Whitworth quick return motion mechanism, right? And the second one will be what? The rotary engine, or we can say the genome engine. You should remember these names. This is very much important. It can be asked in the examination directly. You should remember this particular names. Cylinder fixed, you will be getting this. If the crank is fixed, you will be getting this, right? You should remember this particular names. Okay, we'll be discussing Whitworth quick return motion mechanism in detail with an animation part, and the animation part will help you in visualizing the concept, right? Okay, so now let's suppose the connecting rod is fixed. What will happen? There will be we will be getting what? Two different mechanisms. So okay, the crank slotted quick return motion mechanism, oscillating cylinder engine. Okay, we'll be getting what? The 2 mechanisms, right? If the connecting rod is fixed, we will be getting this particular mechanisms. Remember this particular names. This is very much important, right? Now piston is fixed. If the piston is fixed, piston or slider, we can say okay, hand pump and the bull engine. Remember this particular names. It is very much important. It can be asked in the examination directly. Okay, you just remember the names. But for the analysis purpose, we'll be discussing what? First of all, we'll be discussing the crank slotted quick return motion mechanism, in which the connecting rod is fixed. And second one, we'll be discussing what? The Whitworth quick return motion mechanism. Right? I hope till now everything is clear. To you. Now the analysis part will come. Right? So just move on to the crank and slotted quick return motion mechanism, right? Just have a patience. We will be discussing the crank and slotted part in a detail, and you should just, first of all, you should watch the animation part and try to absorb the visualization part. You should absorb in your mind, because if you absorb that particular visualization in your mind, then you will not face any difficulty in solving the question. First of all, you should absorb, you should visualize this particular mechanism, right? So as we have discussed, we are discussing slider crank mechanism. In that particular case, if the connecting rod is fixed, we will be getting what? The crank and slotted quick return motion mechanism, right? So now this is the animation part. Focus properly on this particular animation. Okay, try to focus on this animation part and try to absorb each and every detail, right? So just focus on this particular animation part, right? So first of all, try to absorb what are the elements in the mechanism. this is the slot, this is the slotted bar in which this slider can slide. Okay, this is one member and this is one member, right? The cutting tool and this member are not the part of a mechanism, right? First of all, understand this thing. Most of the student make mistake here. Most of the student, this cutting tool and this member are not a part of mechanism. We are using this particular elements with the mechanism so that we can use that mechanism in a different applications. Like obviously in the shaping machines we'll be using this. Okay, but remember this thing, this tool and this connecting member is not a part of mechanism. Okay, we are using that particular things just to visualize why we are using this particular mechanism, what we are getting from this mechanism. That's why we have attached this particular things, but this is not a part of mechanism. Remember this particular thing. Okay, many of the students just find it this is also part of mechanism. No, this is not a part of mechanism. This blue, the cutting tool, and this yellow one, right? What are the members? There will be 4 members, right? These 2 are the fixed centers. These 2 are the fixed centers. One is the slotted bar, slider, and this is crank. So where is the connecting rod fixed? The member which is between this 2 points, the member which is between the 2 points is fixed because these 2 are the fixed ends only. So this the connecting member which is fixed, right? This is the slotted bar, second, third is the slider, and the fourth one will be what? The driving crank. This is the driving crank. Now it is rotating completely. That's why we are called it as what? The crank. And this is the slotted bar, which is nothing but the oscillating, with respect to this point only. This member is oscillating with respect to this particular point. So see again this particular animation part. See again. See. This is the cutting tool which we have attached with the mechanism so that we can use that particular mechanism. Ultimately, the mechanism is just for what? For the application purpose, na? We are using that mechanism in different applications, right? So see again, see. First of all, observe this thing. This is the extreme position of a slotted bar. Now, just mark my words. This is what the extreme position of the slotted bar, right? There will be one extreme position and the second extreme position will be like this only. Why we are saying extreme position? How we can say this is the extreme position? Because of this particular position, the cutting tool will be extreme right. Okay, because of this position, this particular position of the slotted bar, the tool will be at the extreme right. Okay, now see, when it come back to this particular position, na, what will happen? See, cutting tool will be at the extreme left. Cutting tool will be at the extreme left, right? The cutting tool will be at extreme left. So that's why there are 2 extreme position for the slotted bar. There will be 2 extreme position for the slotted bar. The first extreme position will be like this and the second one will be like this. So at this particular position, the cutting tool, cutting tool will going to what? Cut the material. This is the position, extreme left position is what? At this particular position, the cutting tool will start cutting, or we can say it is moving forward stroke, we can say, or we can say the cutting stroke, right? See, when it moves forward, na, it does the cutting, and in the return, it does nothing. It will not do anything. So ideally, what should we have? We should have a mechanism in such a way that it will cut the material in a possible way, in a best possible way, so that our workpiece should be cut in a best manner. Okay, but in the return stroke, it will not doing it. It is not doing anything. It is not doing any purpose in it. It is not doing any cutting operation. So at that return stroke, in the return stroke, it should move quickly. It should move quickly. Why I said quickly? Because in the return, it is doing nothing. Nothing productive work is doing by the cutting tool in the return stroke. So ideally, it should come to the original position in a quick manner. That's why we are saying a quick return motion mechanism. But while cutting, it should move in a best possible way. But after completing the cutting, it should come back to original position in a quick manner. That's why we should have a mechanism in such a way that it will come back to its original position in a quick manner, right? That's why we are saying what the quick return motion mechanism. So again see, this is the extreme position of the slotted bar, extreme left position of the cutting tool, and from this particular position cutting will proceed. See, now at this particular position cutting will end. Now the cutting tool has done its cutting operation. Now it will come back. And it is doing nothing productive work it is doing in the return stroke. That's why we should have a mechanism so that it will return back to its original position in a quick manner. Okay, so see, it will quickly return to its original position. I hope this particular animation gives you an idea about the crank and slotted lever mechanism, right? Anyone, if you have any doubt, you can directly ask here. Okay, Abhishek, are you there? If you are there, then if you have any doubt with regards to this particular animation or this particular mechanism, you can directly ask, right? I hope this particular animation gives you an idea about how the mechanism works. What is the application of the mechanism, right? I hope this is clear to you. So we will be moving forward and we will be now analyzing this particular mechanism. We'll be analyzing. So this just gives you a visualization purpose. This animation is just for visualization purpose. Now we will be analyzing this particular mechanism. What we have to calculate? The quick return ratio. We have to calculate the quick return ratio, right? And we should also calculate the stroke length. How much it moves, okay, during the cutting and the return stroke. That is called, what is the stroke length? Okay. So right, again just see this particular animation, because we have to analyze with regard to its extreme positions. So cutting will start from here, cutting ends, now return back. This is the mechanism. Okay, so I think this is clear. Now see the extreme position. Now see the extreme position of the crank and slotted lever mechanism, right? So first of all, see, this is the connecting rod. See, this is the connecting rod. Okay, this will be the extreme position first. This will be the second extreme position, right? Now this is the crank position for the extreme. This is the extreme position of a slotted bar, na? So there will be crank position here. There will be crank position here for this extreme position of slotted bar. Now crank is what? Crank is rotating. Complete rotation will be there for the crank. So it will be having what? A circle only. Now see the slotted bar. This is your slotted bar. This is what? This is your slotted bar, right? This is your slotted bar. Now it will give you an idea. This diagram will give you an idea how we are going to analyze this particular mechanism. Okay, there will be two extreme positions will be there. This is the slotted bar. The driving crank will be there, and the connecting tools will be there. But remember one thing. This cutting tool and this black connecting member are not a part of our mechanism. They are just attached to the mechanism so that we can use this mechanism in our device or our machine. We have used that particular attachment so that we can utilize this mechanism in our machine, okay, to get the desired purpose, to get the desired particular motions, right? Now we are going to analyze, right? Okay, so see, we can use this particular thing. Now see, through this diagram we will going to analyze, right? So this is one extreme position, right? This is another extreme position, right? And this is the slotted bar, the driving crank, and this is what? The connecting tool, right? Now see, what we have to calculate? The quick return ratio. What we have to calculate? The quick return ratio. QRR, quick return ratio. Right? What is this ratio? QRR. It is nothing but the time during cutting operation. during cutting stroke, we can say time during return stroke. Right? The time during the cutting stroke and time during the return stroke. Now just tell me one thing. The crank, you are giving the input motion to what? The crank only. You are giving the input motion to the crank, and the crank is rotating with the uniform angular velocity. This is very much important. Actually, when we are analyzing, we are just focusing on the relation and the formula only. But you should know how that particular relation is developed, how we can get that particular relations. The formula and the relations are important, yes, correct. But the procedure through which we get that particular formula is also important, right? In some situations, direct formula will not help us. So we should know what is the procedure so that we can get particular formula, right? So most important thing you have to note here is that the crank is rotating with constant angular velocity. With what? The constant angular velocity. With constant angular velocity, right? Constant angular velocity. If the angular velocity is constant, see, if the angular velocity is constant, then we can write omega is constant, then we can write what? Omega equals to what? Theta by t. Theta is what? The angular displacement. T is the time taken. And if omega is constant, we can write t is proportional to what? Theta. If the angular displacement is more, the time required will also more. As simple as that. If the angular displacement is more, then the time required to travel that particular angular displacement will also more. Simple, correct? So what is the ratio of QRR? QRR is nothing but the time during cutting stroke divided by the time during return stroke. I can just modify this particular relation. I can modify this relation. How we can modify? We can use for QRR. We can use what? We can use angle. In place of time, we can use what? Angle, because angle is what? The angular displacement, and angular displacement and time are proportional if the omega is constant, right? So angle during what? Cutting stroke. Angle during cutting stroke divided by angle during a return stroke. Angle during a return stroke. Right? I hope this is clear to you. So how we are writing from this particular relation to that particular relation? QRR is nothing but a time during cutting and divided by the time during return stroke. We can modify this particular relation by this: angle during cutting stroke divided by angle during return stroke. Okay, how we can get this particular relation? From the basic mechanics point of view. From the basic mechanics, you can get this particular relation. Right? So always remember this particular relation. And also this relation, and also this relation. Both are important, right? Both are important. So I hope this diagram is clear to you. So both the extreme positions are there, right? Now just tell me the cutting angle during basically angle during cutting stroke and angle during return stroke, right? You know that for the cutting stroke, the tool will move from C1 to C2. And for that matter, we can say this slotted bar is moving from R1 to R2. The slotted bar is moving from R1 and R2. definitely it will not go from straight line. It will not follow a straight line. Definitely it will follow a arc, a circular arc, because the slotted bar is what? It is having a oscillation motion about point A, about point O, sorry. It will move like this. The slotted bar will move like this. Okay. The slotted bar will oscillate about point O. So the slotted bar is having a motion from R1 to R2 during the cutting stroke. During what? During the cutting stroke, right? So definitely, if the slotted bar is this, the position of the slotted bar is like this, it means the extreme position of slotted bar, this particular, for that position the crank will be like this, crank will be like this. And if the slotted bar is like this, the crank position will be like this. Okay. So during the cutting, slotted bar moves from R1 to R2, the cutting tool moves from C1 to C2. I hope this is clear. So what is the angle? Angle is this one. Angle is this one. Let's suppose we call it as alpha. You can say it by another name, beta, gamma, anything, whichever you find suitable. So angle alpha is nothing but the cutting stroke angle. And please try to visualize how we are saying this particular angle as a cutting stroke angle, because we know that before the cutting, basically during the cutting stroke, the slotted bar will move from this position to this position, right? You should visualize in your mind, during cutting operation, the slotted bar will move from this position to this position, right? It means R1 to R2, C1 to C2. It will move like this only. So obviously the cutting stroke angle will be like this only, right? Now, what is the return stroke angle? What is the return stroke angle? Return stroke angle is nothing but this one, beta, right? I hope this cutting stroke angle and the return stroke angle is clear to you. If there is any doubt, you can ask. You may please ask the doubt. If you have any doubt with regards to alpha and beta, you can ask, because this is very much important. You should not just remember this particular formula, but you should also able to visualize this particular mechanism and find out the angle. It is not just like that. If the time is given, both the time are given, and directly you are finding the QRR. In the GATE examination, it will not be there. Direct formula based questions will not come in the GATE examination. There will be some application. You have to do some little hard work while solving the question. And for that, you should know the basic fundamentals. That is very much important, right? I hope alpha, beta are clear. So now we can say the QRR is nothing but alpha by beta. But you should know what is alpha and what is beta. Alpha is nothing but a cutting stroke angle and beta is nothing but a return stroke angle, right? Alpha, beta, you should know. What happens actually, the student directly remember this particular formula, but you should know what is alpha, what is beta, and you should be able to calculate alpha and beta from the given diagram by visualizing how the mechanism will work. We'll be solving some GATE question with respect to this particular topic, no problem. We'll be solving, and you will be confident enough while solving that questions. You will be confident enough, and you will be solving any new question from this particular topic. It may came in your GATE 2022. It may came, but for that you should solve the previous year questions and try to understand this particular concept, right? I hope this is clear to you. So always remember how we are saying this is alpha and this is beta, right? There is one more thing which you should know. There is one more thing. Always, whenever the question came from the crank and slotted, just first of all you should draw what? The extreme positions. You should draw the extreme position, right? Let's suppose I will draw the extreme positions, right? I will draw extreme positions. Right, these are the extreme positions. So let's suppose this is the crank. Now you should know. This is the slotted bar, this is the crank, and it will be having this 90-degree angle. it will be having a 90-degree angle, right? So let's suppose I am calling it by name O, this is A, and let's suppose this is B1, and let's suppose this is B2, right? I've used the same nomenclature, okay? I've used the same nomenclature which we have discussed in the last slide. OA is nothing but your connecting rod, okay? I will mention this particular point. OA is nothing but the connecting rod. You should know this. This is the connecting rod, which is fixed. Which is what? Which is fixed, right? Now see, this is the connecting rod and this is what? The driving crank. Why I say driving crank? Because the input motion is given to the crank only. Input motion is given to what? The crank only. And because of the input motion given to the crank, the slotted bar will oscillate. The slotted bar will oscillate, and if the slotted bar oscillate, the cutting tool will also oscillate. And this mechanism you will find this mechanism in the shaping machines. Okay, application. If I talk about the application part, you will find this mechanism in the shaping machine only. Okay, so this is clear. Driving crank, connecting rod, this is clear to you. Now see what we have said. This is what the just one second, I will remove this A. Right. So let's suppose I'm talking about the cutting angle alpha. This is what? Return stroke angle beta, right? Now see, this angle is beta. Obviously, this particular angle will be beta by 2, right? I hope this is clear to you. This particular angle will be beta by 2. Let's suppose I make it large, okay? Let's suppose I make this diagram a little bit large so that it will be clear to you. So this angle will be beta by 2, right? Now see, in the triangle OAB1, see, in the triangle OAB1, you can write what? In triangle OAB1, okay? Correct? In the triangle OAB1, you can write what? Cos beta by 2. You can write what? The cos beta by 2. Cos beta by 2. Cos beta by 2. Basically, cos means what? The base upon hypotenuse, na? So, in the front of angle, this will be what? Perpendicular. Base will be what? B1A1. B1A basically. And the hypotenuse will be what? OA. OA. Now see, B1A is nothing but the driving length of the driving crank. OA will be what? The length of the connecting rod. Both will be given. If both will be given, you can directly find the angle beta. And if you can find the angle beta, you can find alpha also. How we can find? By simple relation, na? Because you know alpha plus beta will be nothing but what? 360 degree. Right? Alpha plus beta will be what? The 360 degree only. So if you able to find beta, you can directly find the alpha from this particular relation, right? If beta is clear to you, then you can easily find alpha also, and you can directly find what? The QRR, quick return ratio. Quick return ratio. Now QRR is clear to you. Now second point is what? The stroke length. If you want to calculate the stroke length, how you can calculate the stroke length? Just see. How you can find the stroke length? First, you should visualize what is the stroke length. What is the stroke length? You should visualize this. See, stroke length will be what? R1, R2 or C1, C2. We can say R1, R2 and C1, C2. Both will be the stroke length. We want to calculate R1, R2, let's suppose, because this will be only our stroke length. How we can find R1, R2? See, in this particular image, we can find out. In this particular image only, we can calculate the stroke length. So again, we'll be drawing just the extreme positions only. Just quick diagram will be there. right? This will be there. So now we are saying the stroke length. We are talking about the stroke length like this. This is the stroke length, right? Now we want to calculate the stroke length. How we can find out? Just see. This will be the driving crank. It will be having a 90 degree. This is O. This is A. This is B1. Let's suppose this is B2. This is R1. This is R2. Right? Simple basic mathematics. Simple basic mathematics. You have to use just simple basic mathematics tools. You can easily find out the what? The stroke length. So stroke length will be what? Stroke length will be R1, R2. Okay, or we can say C1, C2, both are same. We can write R1, R2 as what? Let's suppose if I extend this. Okay, if I extend this particular thing, let's suppose this is P. Let's suppose I take it as P, this particular point. So it will be nothing but the twice of R1P. It is nothing but twice of R1P, right? Just use just basic mathematics. You have to use just basic mathematics, okay, right? To twice R1P. Now in the triangle of what? OPR1. In the triangle OPR1. In triangle OPR1, right? Just see. In triangle OPR1, you can write what? See. This angle is what? Beta by 2. Right? This is 90 degree, this is beta by 2. Obviously, this angle will be what? 90 minus beta by 2. Just from a common sense, na? The interior angles of the triangle will be what? The 180 degree. So, this is 90 minus beta by 2, this is beta by 2, this is 90 degree. The total summation will be what? 180 degree only. Now see, in triangle OPR1, if I use the what? Let's suppose I use the cos angle. If I use the cos angle, this is the angle. In front of angle will be what? This is the base. This is the perpendicular height. So let's suppose I am using sine 90 minus beta by 2. Perpendicular divided by hypotenuse. Let's suppose I am using, because this is the angle. This is the angle. In front of angle will be the perpendicular. So R1P will be the perpendicular. R1P will be the perpendicular divided by hypotenuse. Hypotenuse will be nothing but OR1. OR1 will be the hypotenuse only, right? OR1 will be the hypotenuse only, right? And what is OR1? OR1 is nothing but the length of slotted bar. OR1 is nothing but the length of slotted bar only, right? So we can write it here. Sin 90 minus beta by 2 will become cos beta by 2, right? R1P, we get the value of R1P. What is OR1? Directly we can say it is the length of slotted bar. The length of slotted bar. It is nothing but the length of slotted bar, right? But what about cos beta by 2? But what about the cos beta by 2? We can write cos beta by 2 what? See, again here. Cos beta by 2 in case of triangle OB1, OAB1, in triangle OAB1, right? Let's suppose I am using in triangle OAB1, I am using cos beta by 2. Just see the basic mathematics part. If you are strong at the mathematics, definitely you will do the questions quickly. Okay. For engineering, the mathematics part is very much required, right? So you should be good at mathematics. So in triangle OAB1, we can write cos beta by 2 as what? This is the angle. In front of angle will be perpendicular. This one will be the base upon hypotenuse, that is AB1, divided by what? Hypotenuse. Hypotenuse will be what? OA1. OA, simply OA. And what is that? AB1 is nothing but the length of crank. Length of crank divided by OA is nothing but the length of connecting rod, right? Length of connecting rod. In short, I am writing CR. In place of connecting rod, I am writing CR. Now we know the value of cos beta by 2. We can directly use this value of cos beta by 2, that is length of crank divided by length of connecting rod. Okay, see, we have taken this triangle, then we have taken this triangle. Now we will be using this particular values, this particular relations into this relation. We will be putting these values here only, right? See, so finally what we will be getting is stroke twice of R1P. In place of R1P we can multiply cos beta by 2 into length of slotted bar. Length of slotted bar multiplied by cos beta by 2, and putting the value of cos beta by 2 we will be getting the entire formula for the stroke only, right? So it will be what, 2 into length of slotted bar, 2 into length of slotted bar, right, into cos beta by 2. What is the value of cos beta by 2? Length of crank divided by length of connecting rod. Length of crank divided by length of connecting rod. Length of connecting rod, right? Right. So if you know this particular formula, then obviously if the length of slotted bar is known, length of crank is known, length of connecting rod is known, you can directly use this particular values to find out what the stroke length. It is very much important formula, and you should remember this particular formula because question may came in your GATE 22 examination. GATE 22 examination, the question may came, and if you know the formula, if you know this particular formula, you can solve it, the question, you can solve the question in a less than 10 seconds only. In the less than 10 seconds, you can solve this particular question. Question with regards to what? The stroke length. We'll be solving some questions. We'll be solving some questions with respect to what? The crank and slotted lever mechanism and also the width worth. So first of all, we'll be discussing, or what? We are analyzing the system, and in the analysis part, we have covered two things: the QRR part and the stroke length part. I hope this is clear to you. Okay. See, so this particular formula should be remembered. Okay. Put this formula in your notes, in the short notes, or you may call it as a formula sheets. You should make some formula sheets for every subject in which there are only formulas are there, because at the in the last moment you should revise the important formulas only. No, you will not revising the theory part. You will be revising what? The formulas. So make the formula sheets. Make the formula sheets because it will help you in revising in the last moment, just before the examination. It will help you. Okay, just make the formula sheets and make it as concise as possible. Make it as concise as possible, so that let's suppose if I talk about a theory of machine, there are, let's suppose, 10 chapters. Complete the 10 chapters in 10 pages only. One page for the one chapter only. Make the concise formula sheets. Okay, it will help you in revising at the last moment. Okay, so this particular formula you should remember, right? I hope this is a very simple thing, and each and everything will be clear to you, right? Now we'll be going to discuss what? The Whitworth quick return motion mechanism. Whitworth quick return motion mechanism, just the last topic for the today's session. What? The Whitworth quick return motion mechanism. Then we will be solving some beautiful questions. First we'll be solving some solved questions, then PYQ. And this year only the Whitworth topic, the question related to Whitworth topic has came in GATE 2021. And before that, you will not find any question with respect to Whitworth. And most of the students may find it difficult because in general, you find there will not be any discussion with regards to Whitworth. Because generally, people skip this particular topic. Why they skip? Because no question has been asked. It is not like that. Question is not asked in the previous year examination. It will not be asked in the upcoming examination. It may came in the upcoming examination. So we should focus each and every important concepts. No matter it has been asked or not, important concepts should be prepared for the GATE examination, right? So remember in the starting we have discussed, if we fix the crank, we will be getting what? The width worth quick return motion mechanism. Remember what we are fixing? The crank part. We are fixing the crank part, so we are getting the width worth quick return motion mechanism. Second one will be what? The rotary engine, genome engine, right? But this one is important as far as gate is concerned. As far as gate is concerned, this is very much important, right? So we'll be analyzing this, but before that, you just see the animation part, the beautiful animation part just for you guys only, because this animation will clear the doubts, any confusions with regard to width worth. Crank and slotted, it seems okay, it's very simple, I know, but in the width worth, the crank is fixed. In width worth, the crank is fixed, so students find it very confusing. So while solving the while watching this particular animation, all the doubts, all the confusions will be cleared. Just attention, just focus on this particular animation that we are going to discuss now. Just focus on the animation part, right? Closely observe, just closely observe the animation part, right? I'm going to play this particular animation, right? Just closely observe this particular animation, closely observe, right? Now, first of all, you should appreciate what are the different members are there. You should appreciate this thing. Again, here also the cutting tool and this member are not a part of mechanism. First of all, clear this doubt. This cutting tool, red one and this gray one are not a part of mechanism. So what are the parts of mechanism? This black one, this green slotted bar, this yellow, and this circle one. This is nothing but a slider only. This is nothing but a slider only, right? Now, observe. Now, this is the cutting tool and it is on the extreme left. Now, again here, we will be focusing on the extreme positions. Extreme position with regards to what? With respect to what? The extreme position of the cutting tool. Our cutting tool is on the extreme left. While cutting, it will move on to the extreme right, okay, and the cutting part will be over. While returning, it will move from extreme right to extreme left. While returning, it will move from extreme right to extreme left, and while cutting, it will move from extreme left to extreme right. Just closely observe this particular thing. Now cutting will start. Okay, now cutting will start. See. Now cutting will start. So as you see, the cutting will end here. Cutting will end here because the cutting tool is at the extreme right. Now cutting will end here. So what will happen? The cutting tool will quickly move to its original position. The cutting tool will move to its original position, right? Right. Now see the return stroke. It goes like this. I hope this animation part is clear to you. If you have any doubt with regards to this particular animation or anything, you can ask directly. Because you should not have any confusion while watching this particular animation. I think every confusion should be cleared. Okay, right? Again, closely observe this particular animation. Closely observe. See. Again, from the starting we'll be observing. From the starting we'll be observing. See. Right. The cutting tool is at the extreme left. Now it will move forward. That is, the cutting stroke will be there. From the extreme left to extreme right, it will move. Now see, this yellow one, it is what? It is the driving crank. Now observe the each and every part of the mechanism, each and every link of the mechanism, and what the role has been played by the every link. You should note it down. The role played by the each and every link, you should note it down, right? So yellow part, it is nothing but the driving crank. It is nothing but the driving crank. It is rotating completely. That's why we are showing it is a driving crank. So it is just before the cutting proceeds, the position will be like this only. Okay, so this is the extreme position. Now cutting will start. Now it will be straight like this. Now the cutting will end here. Cutting will end here. Now this will be the second extreme position of the yellow member, and the yellow member is having a complete rotation. See, now see, yellow member is having a complete rotation. Yellow member is having a complete rotation. Yellow member is having a complete rotation. That's why it is a driving crank only. But see the green part, green member. Green member is what? The slotted bar. The slotted bar is also having a what? Complete rotation. Slotted bar is also having a complete rotation. Again see, yellow member, that is the driving crank, is having a complete rotation. That's why we are call it as crank. But the green member is also having a complete rotation. So here the input is crank, input is complete rotation, output you are getting is also complete rotation. We can say like that, na? But you should know, we are using in this particular mechanism, rotation to rotation will be there. Rotation to rotation will be there. But in the crank and slotted, there will be crank to oscillation, rotation to oscillation will be there. Rotation to oscillation. In the case of crank and slotted, rotation to oscillation. But in this particular mechanism, we will be having what? The rotation to rotation only, right? But how we are using this particular mechanism, the real life application will be what? The shaping machines only. See, as you all know, the yellow member is having a complete rotation. That's why we are calling it as a driving crank. But the green part is also having a complete rotation. So slotted bar is also having a complete rotation. But because of complete rotation, this member is connected like this only. This member is connected to this end, right? Now see, it will also rotate in a complete sense, but only this part is having a complete circle. This part is having a complete circle. I am talking about this particular part. See, this particular part and this particular part is having a complete rotation. Basically, we can draw a circle. We can draw a circle from here. Let's suppose if I use let's suppose if we use ink in the slide, let's suppose, yeah, blue one. Just see. No problem. We can use in a different note section also. But see, but clearly observe, there are two circles will be there. There will be two circles will be there. One circle will be of what? The yellow driving crank. The one circle will be for the driving crank, but another circle will be for this particular member. Another circle will be for this particular member, right? Remember this one. Why we will not have a circle for this point and this point? Because this point is moving in the slider, in the slotted bar. Because this is a slider, na? It will slide in the slotted bar. We will not having a fixed point. The fixed point are this. This is the fixed point, this is the fixed point, and both the fixed points will have a complete circle, right? Similar manner, in the similar manner, yellow member will also have a complete rotation, right? Okay, I hope this animation is clear to you. Now we will be visualizing the extreme positions of this particular mechanism, as we have discussed in the previous crank and slotted also. Now see, I hope the mechanism part is clear. Right? Now see, first of all, crank is fixed. The crank is fixed. This is the driving crank. Just remember one thing. This is the crank. This is the crank. This is the crank which is fixed. Because in the Whitworth quick return motion mechanism, crank is fixed. Okay. Crank is fixed. Now the driving crank will be like this, right? Now this is the slotted bar. Now this is the slotted bar. Please closely observe this particular thing. This crank is fixed. This is the driving crank. This is the driving crank. This crank is fixed. This is not moving. This is the driving crank. Now see the slotted bar. See the slotted bar. Right? Now observe where the circles, where will be the perfect complete rotation will be there because of the driving crank. Secondly, in this particular length, for this particular length, because this point is also fixed, this point is also fixed. So we'll be having a two circles will be here. Now see, we'll be having a two circles here. one circle will be for this driving crank, one circle will be for this driving crank, right? But another circle will be for this particular point and this particular point, right? Now see, obviously this will be the turning pair, this will be the turning pair, this will be the turning pair, right? Now the extreme positions will be like this only. Extreme positions, always while we are analyzing, we are focused on what? We focus on the extreme positions. Now in this particular case, extreme positions are like this only, this one, this one. This is what the driving crank, this is what the driving crank, right? But in this, why the confusion happens in the Whitworth quick return motion mechanism? Because it is little bit difficult to visualize what is the cutting stroke angle and what is the return stroke angle. For that, again see the animation part. Where will be the cutting stroke angle will be there? Where will be the cutting stroke angle will be there? Just again observe the animation part. Again closely observe. See, from this particular point the cutting will proceeds, okay? So driving crank from here to here. Now the cutting driving crank, the yellow member will be like this only. When the cutting proceeds, the driving crank will move in the clockwise. The driving crank will rotate in a clockwise direction, right? The driving crank will rotate in a clockwise direction, and after this it will came to this particular position. See, yellow member is having a clockwise motion. Yellow member is having a rotation in the clockwise direction. Before cutting it is here, after cutting it is here. So this will be what? The two extreme position. This will be what? The extreme position of the driving crank. First, the extreme position will be like this at the start of cutting, and after the end of cutting, the yellow member will be like this only. So two extreme positions are there, right? Now I hope this is clear. So what is the cutting angle? Cutting angle will be like this only. Cutting angle will be like this only. Okay. Now see, fixed crank, driving crank, slotted bar. Two circles will be there like this only. The turning pairs are there. Now what? The fixed, basically the extreme positions are there. First extreme position, second extreme positions, right? Clear? Now we are analyzing this particular diagram only. In both the cases, crank and slotted and the Whitworth, in both the cases we are analyzing what? The extreme positions. So you should be familiar with the extreme position diagram of both the mechanisms, right? Now see, we'll be using the diagram only. Now see, this is the diagram, the extreme position diagram of a Whitworth quick return motion mechanism, right? So what I've said, what is the cutting stroke angle? Cutting stroke angle will be like this only. This is your cutting stroke angle, right? Alpha. And what will be the return stroke angle? Return stroke angle will be like this only. Let's suppose it is beta. And let us suppose again this angle is beta by 2. Obviously this angle will be what? Beta by 2. I hope this is clear to you. This angle is what? The beta by 2 only, right? I hope this is clear to everyone. This angle is what? The beta by 2. And if this angle is beta by 2, we can write what? We can write, let's suppose we can write cos beta by 2. Let us name the points here. This is O. Let's suppose this is A. Okay, OA, let's suppose. Base upon hypotenuse will be there. Cos will be what? The base upon hypotenuse. Base is what? In front of angle, this is the perpendicular, this is the base, right? The base will be what? OA, right? OA will be the base. And what will be the hypotenuse? Hypotenuse will be what? This driving crank. Isko we can write this is at what? This is at extreme position of, we can write extreme position of driving crank. We can write it as the extreme position of driving crank before cutting. Now it will be clear to you. Before the cutting, this will be the extreme position. Before cutting, this will be the extreme position of the driving crank. So we can write OA. Let's suppose this is C. Let's suppose this is C. OC. Now you should know cos beta by 2. OA is nothing but what? The fixed crank. Length of fixed crank. And it will be given to you in the question. It will be given to you. Divided by OC. OC is what? The length of driving crank. In the question, all the details will be given. All the details will be given to you. So it is very simple, na? It is very simple, right? It is very simple. So if someone asks you, calculate the QRR, if the dimensions are given, let's suppose the dimensions of a fixed crank and a driving crank is given, it means you can calculate the beta angle, and if you can calculate the beta angle, you can calculate the alpha angle. How? By simply using what? By simply using alpha plus beta equals to what? 360 degree. This is the relation you can use. This is the relation you can use. If you can calculate the beta, you can calculate the alpha. It is very simple, right? So from this relation, if the beta is known, you can calculate alpha, and if both angles are known to you, then you can directly find what? The QRR, the quick return ratio. You can find out what? The quick return ratio, and it is nothing but angle during the cutting stroke divided by the angle during the return stroke. You should remember the QRR formula by this in this way only, not the alpha by beta. Alpha beta are just the notation. So remember, learn this particular formula. Remember, keep this formula in your mind, QRR, in such a way that it is like that. What? How it will be like? It will be the ratio of cutting stroke angle divided by the return stroke angle. It will be what? The ratio of cutting stroke angle divided by the return stroke angle. You should remember the formula like this only, not the alpha by beta terms. Okay, these are the just notation only. I hope this mechanism is clear to you. I hope this mechanism is clear to you. But if someone asks what is the stroke length, what will be the stroke length, how you can calculate the stroke length? First of all, if you have any doubt, just see what will be the stroke length. So this cutting tool and this member is attached to this particular position. In the same way as we have discussed in the crank and slotted, obviously the this cutting tool is moving from extreme left to extreme right during the cutting stroke, and the return stroke, it will be moving from extreme right to extreme left, right? Absolutely. Now just tell me, the cutting tool and the member is connected to this position, na? So what will be the stroke length? What will be the stroke length, and how you can calculate the stroke length? It is very simple. Just observe the diagram. This member is connected to this particular point. Obviously, this point A and E. A, let's suppose I will give a name A or OAB. Let's suppose I am giving a name E. Let's suppose I am giving a name E. So AE will be having what? A circular motion, because this point is fixed, and as you all know, the slotted bar is having a complete rotation. So that's why AE is also in a complete rotation, and E is the point where the attachments are connected. So the twice of AE will be the stroke length. Twice of AE will be the stroke length only. Correct? This is a very simple case. Just you have to visualize and how the stroke length will be there, and how we can get the stroke length. Stroke length from what we can get? Basically, we are talking about the movement of the cutting tool. Na? Just observe the movement of cutting tool, and how the cutting tool is connected to the mechanism. Just observe that part only, right? So twice of AE will be the stroke length only. Twice of AE will be the stroke length. So just for your information part, you should know, during the cutting stroke, the driving crank, during the cutting stroke, what happens? The driving crank moves from OC. Let's suppose I put it as what? OC1 to OC2. The driving crank moves from OC1 to OC2, because initially the driving crank will be there at extreme left position of the cutting tool. That's why I have written the extreme position of driving crank before cutting. So this is the extreme position. When the cutting proceeds, it will move like this. It will move like this and it will come to this particular position. And at this position, cutting will end. Right? Before the cutting, the position of the driving crank will be like this only. And when the cutting proceeds, it will move like this. It will move like this and come to this position. And at this position, the cutting will end. I hope this is clear to you. I hope this is clear to you. Right? So during the cutting stroke, we can write driving crank moves from OC1 to OC2. Right? Driving crank moves from OC1 to OC2. Correct? I hope this is clear to you. Right? This is the very much most important part. Very important, because students find difficulty in visualizing this the mechanism. If you able to visualize the mechanism, then they will not face any difficulty. You will not face any difficulty in solving the question, right? So I hope till now we have discussed the slider crank mechanism. In the slider crank mechanism, we have discussed two topics. First one, what? The crank and slotted lever mechanism. Second one is what? The Whitworth quick return motion mechanism. I hope both the mechanisms is clear to you. If there is any doubt, you can ask, or you may ask the question in the comment box also. We will reply as soon as possible. Okay. If in a case you have any doubt after watching the session, you can ask in the comment box also. No problem. We can solve your query as soon as possible, right? You can ask in the comment box also, right? So I hope both the mechanisms are clear. We have discussed the animation part. We have discussed the analysis part. Okay, complete discussion is covered. Complete discuss. Okay, we have completely discussed everything. Now we will be solving some solved questions. We will be solving some questions, sample questions. Then we will be solving the PYQ, previous year question, right? Now just move on to the question part. So question came here. So this is the question. Just solve the question and give me the answer. It's a very simple question. Slider crank mechanism, basically the crank and slotted lever mechanism. Just solve the question as soon as possible. The shortest possible time you should solve this particular question. It's a very simple question, right? Just solve this question. Just solve the question. Try to solve this question. It's a very simple question. Just basic, simple. Try to solve. If you are able to solve this question, definitely the PYQ will be very easy for you. Not even the PYQ, the question which may came in the GATE 2020 examination, that also very simple. That will be a very simple for you only. Okay. Just try to solve this question. Very simple question. Anyone, if you get the answer, please tell me fast. If you get the answer. Fast. I need the answer. Correct? Just solve it. So, if I read, the question has given for the quick return motion mechanism, C. A and C, the two fixed points are there. BC will be what? This will be nothing but your driving crank. It is not. It is what? It is the crank only. This is the slotted bar, and the slotted bar is having what? The slider only, right? Right? Just see again. See. See. In this particular diagram, see, this is the slider, right? This is the slider. This is the slider. This is the crank. This is the crank. And this is what? Slotted bar. This is what? The slotted bar. Right? This is what? The slotted bar only. very simple things. Slotted bar, okay, slotted bar, slider, crank, all are there, right? All are there. And what we have to calculate? We have to calculate the time ratio of the working stroke to return stroke. Basically, it is asking about what? The QRR only. It is asking about the QRR part only. Okay. So what is QRR? You already know what is the QRR part. QRR, we can say QRR is nothing but the angle during what? Cutting stroke. Okay, you should remember this particular formula, during cutting divided by angle during return. How we should approach this particular questions or this type of question? What will be the procedure? What should be the approach? First of all, you should draw the extreme position diagram. First of all, you should draw the extreme position diagram. Then only we can solve this particular question. So first of all, we will be drawing what? The extreme position diagram. See, the extreme position diagram will be like this only. I am making a rough diagram here. Let's suppose this is a rough diagram of the crank and slotted lever mechanism. So this is the extreme positions. These are the extreme positions. So I will be mentioning the values. So in the question given, AC length is given as 80 mm and BC is given as 20 mm, right? It is given as what? 80 mm and it is given as 20 mm, right? Correct? These dimensions are given to us. Now we should know this particular angle is what? Beta by 2. This is what? The beta by 2. And from the basic trigonometry, you should know we can write cos beta by 2. It is what? The base upon hypotenuse. Base will be what? 20. Hypotenuse will be what? Hypotenuse will be what? 80 mm. 20 divided by 80. So from this relation you will get beta. And if you get the beta, you can directly find the alpha. How? Using alpha plus beta equals to 360 degree. Using this particular relation, alpha plus beta equals to 360 degree. So if you can get the beta, you can directly calculate the alpha part also. If you know alpha and beta, you can find the QRR. Simply QRR will be what? Alpha by beta only. Angle during cutting stroke divided by the return stroke only. I hope this question is clear to you. Okay. So let me give you the answer. For the beta value will be what? 151.04 degree, right? Just check the answers. Beta value will be what? 151.04 degree and the QRR will be what? 1.38. We'll be getting 1.38 after solving this particular values. Okay. So beta will be 151 and the QR will be what? 1.38, right? The simple question only. Now solve this question. Solve this question again, and it is what? It is the directly formula based question. In this particular question, you don't require any diagram. In the previous case, we need the diagram. We should draw the extreme position diagram. But in this particular case, you should not need any diagram. You don't have to draw extreme position diagram, right? You don't have to draw any extreme position diagram. Why? Why? Because directly question has been asked from the length of the cutting stroke. Length of the cutting stroke has been asked from this question. Yes, exactly. 1.38 is the correct answer. Right, exactly. But if we talk about the length of the cutting stroke, we have discussed a direct formula. For the case of crank and slotted lever mechanism, we have discussed a direct formula. If you have to calculate the cutting stroke length, there is a direct formula. You can use directly the formula. If someone don't know the formula, he may have to do the analysis. Okay, you have to do the analysis, then only he get the relation of the cutting stroke. But you know the formula, you can solve this question within 10 seconds only. Within 10 seconds only you can solve this particular question if you know the formula, right? Just tell me the answer. Just tell me the answer of this question. Just try fast. What will be the answer? Remember, the always try to remember this particular formula. Twice into what? The length of slotted bar. Length of slotted bar into what? Length of crank. Divided by what? Length of connecting rod. Right? Length of connecting rod. So always try to remember this particular formula. If the question asks from the cutting stroke, directly use this particular formula, right? So answer will be what? Answer will be the 500. If you put the values, you will be getting what? The answer 500, right? Directly formula based question will be there. Question may ask in the gate also. This is the formula based question, directly formula based question. I hope these questions are clear to you. Now we will be solving the PYQ. Now we will be solving what? The PYQ part. Now the PYQ part, in the GATE 2021, this question has been asked from the Whitworth quick return motion mechanism. Whitworth quick return motion mechanism. The question has been asked from the Whitworth quick return motion mechanism. Just try to solve this question. Very simple. Very simple. Just observe the motion. Observe the mechanism part. We have already seen the animation. You have already seen the animation, na? So there will be some visualization of the mechanism in your mind. Always try to visualize that particular animation. And if you try to recall whatever you have seen the animation, then you easily solve the question. You will be able to easily solve the question, right? Just try to solve. Every dimension has been given. OA. First of all, remember. First of all, this is what? This is your fixed crank. This is what? This is your fixed crank. What is OP? OP is your driving crank. OP is what? The driving crank. OP is what? The driving crank, right? OP is what? Your driving crank. RP, or we can say the RP is nothing but the slotted bar only, okay? Rest, this is the cutting tool, this is the member, this is not the part of mechanism. This is not a part of mechanism. We don't need that also. But we have to calculate what the quick return motion mechanism. Remember, when we are analyzing the Whitworth quick return motion mechanism, in that particular part, the extreme positions, we have drawn the extreme positions, and if we have to calculate the QRR, we should know only two things. We should also know the two things. What are those? The fixed crank, the driving crank. Only two things are required. Only two things are required, the fixed crank and the driving crank. Again, see, we have already discussed that particular part, na? See, we have done the analysis part, na? So if you have to calculate the QRR, you can use directly the formula alpha by beta. But how you can calculate alpha by beta? First you calculate the beta. How you can calculate beta? You know the cos beta by 2. The cos beta by 2. What will be the cos beta by 2? OA by OC. In this case, OA by OC. OA will be the base, OC will be what? Hypotenuse. And what will be the base? Length of fixed crank divided by the length of driving crank only. And both the part has been given in the question itself. Both the values has been given in the question itself. So it will be very easy. It will be very easy if you know the analysis part. If you know the analysis part, then it will be very easy for you to solve this particular question, right? So it will be very easy. So whether it is a crank slotted lever mechanism question or the Whitworth quick return motion mechanism question, you have to draw what? The extreme position diagram. You have to draw the extreme position diagram. If you are able to draw the extreme position diagram, then only you can solve the question. Any question, whatever has been asked, you can directly solve it. But you should know how to draw the extreme position diagram, right? So in this particular question, let's suppose I am solving, let's suppose this question. Simple. Just in a simple sense, I am drawing this particular question. Just simple diagram. Using the simple, just use the rough diagram. In your mind, you should have this particular diagram. In your mind, you should have this particular diagram. In your mind, you should keep this particular diagram. Okay, there will be two circles are there, two circles will be there, one above circle will be the smaller one and a below one will be the large one, because obviously the driving crank will have a more length in general we can say, right? So this extreme position diagram we have to draw, this extreme position diagram we have to draw. OA is directly given, OC is directly given, just put the value in this formula cos beta by 2, directly put the values, you will get the beta. If you get the beta, you can calculate the alpha from this particular relation, and alpha beta are known, then easily you can calculate what? The QRR, cutting stroke angle divided by the return stroke angle, right? Okay, so directly solving the question, we'll solve this question. Okay, we'll be solving this question. So again, the rough diagram will be like this only. The rough diagram will be like this only. Let's suppose the diagram is like this. Let's suppose the diagram is like this. Okay. Now just a simple diagram only. No need to be a perfect in the diagram, but you should have a clear understanding what we are going to draw. Okay. So let's suppose this is beta by 2. Okay. This is beta by 2. This length is given to you. This length is given. OA is given what? 150 mm, and the driving length is given as what? OP. OP is 300 mm, right? OP is 300 mm. You have been given this as 300 mm, and this is given as what? The 150 mm, right? You just have to use cos beta by 2, right? Because you should know this is this angle is what? Alpha, and the remaining angle is what? Beta only, right? So this will be what? 150 divided by 300, right? So cos beta by 2 will be what? 1 by 2. It will be what? 1 by 2 only, right? Cos beta by 2 will be 1 by 2 only, right? Now see, you can calculate the beta, and if you can calculate the beta, you can calculate the alpha also. And if you know the alpha and beta, directly you can solve QRR as what? The alpha divided by beta, and the answer you will be getting what? As 2 only, right? Because at what angle the value will be half? 60 degree, and what will be the value of beta? 120 degree, and it is 120 degree, then definitely it will be what? The 240 degree, right? Because the summation will be what? Ultimately 360 degree, na? So what you are getting? The QRR will, you will be getting what? The 2. The value of QRR will be what? 2 only, right? So this is a simple case. This is a very simple case. You have to just know, you should have the basic understanding of what? This extreme position diagram only. If you know this extreme position diagram, then you can easily solve this question. So always remember this particular diagram, right? Always remember this particular diagram. Always have this image in your mind. Always. Just try to draw this image multiple times. You can able to solve this question. If you just practice a lot on this particular part, because in this diagram there will be some confusion will be there. How the two circles are made? The circles are only made when you know the analysis. You know about the circles part only when you know the mechanism, how the mechanism work. If you know the how mechanism will work, then definitely you will be able to know how the circles are made, what link are having the circles, right? That's why I am focusing on this particular image only. Please try to observe this image and keep in your mind. How can you keep this particular image in your mind? By practicing this particular diagram. Just draw this particular diagram on your own multiple times. If you draw this diagram on your own by multiple times, then definitely this image will be settled down in your mind. And definitely while solving any question with regards to with reference to what? The width worth, you will be able to solve the question because the image will be there in your mind, na? That's why. So I hope the question is clear to you. Okay, the question will be clear to you. So actually, if the concept is clear to you, if the concept is clear to you, so you will not find any difficulty. Okay, so in just a rough sense, I have drawn this diagram, but actually, what will happen? What will happen? I have to just draw this diagram like this only, like this only. Okay, I have to like this. Let's suppose I use a different color. Like this. So it will be like this only, not a perfect circle, but it's okay. Right. Now, move on to next question. Move on to next question. Let's suppose move on to next question. Just solve this question. Again, very simple question. Question will be very simple for you only when you know the basics. If you know the basics, if you know the mechanism working, if you know the animation part, if you know the working of how the different parts will be moving with respect to each other, then every question with respect to the slide diagram mechanism will be very easy for you. Will be very easy for you. Just try to solve this particular question. Just try to solve this particular question. Very easy one. Again, a crank slotted lever mechanism, right? What is asked? The distance d is asked. This distance d is asked, and what is given? Directly. What is given? Directly you can find what? In the given section, 2:1. Abhishek, 250. 250. Yes, exactly. Correct. Absolutely correct. So again, it means that you have clearly observed the animation part, clearly observed the analysis part, then only you can able to solve this question. Very good. The answer will be 250. Again, simple, use the trigonometry, na? But before using the trigonometry part, basic mathematics part, you should know the working of the mechanism. If you know the working, then it will be very easy for you. Right? So answer will be 250, right? Exactly, Abhishek, you are totally correct. Right? I don't think it is solution is required. It's because it's very simple. Just use the trigonometry part, right? Let's suppose we can solve it for you only. QRR is directly given as what? 2. It means what? Alpha by beta is what? 2, right? Obviously, alpha by beta is given as what? 2. And it is given as what? The radius of the crank O1P is what? 125 mm, right? And you should know alpha plus beta is nothing but the 360 degree. Alpha plus beta is 360 degree. You should know the relation. You know this relation. Alpha by beta, because it is given as 2. Directly you get the values of beta. If you get the value of beta, directly you can use the beta by 2. Just draw the extreme position diagram, na? Just draw the extreme position diagram. This is the extreme position diagram. This will be what? Beta by 2. So cos beta by 2 will be what? Length of crank. Length of crank is nothing but the O1P. O1P, and it is what? O2. So it will be what? The base upon hypotenuse. Base is what? O1P divided by hypotenuse. That is O1 O2. O1 O2 is nothing but the D only that has been asked in this question, right? It is very easy. So very easy. The 250 will be the correct answer. 250 will be the correct answer. Just use this particular relation. You will be getting what? Alpha and beta. Beta is required. Directly put alpha cos beta by 2 formula. The cos beta by 2 relation, just a trigonometry only, right? And last question for this session. Again, very simple. Just quickly solve this question. Abhishek, just solve this question as soon as possible. I think for you it is very easy question. Just make sure the question If the question is easy, then definitely your calculation part while solving, it should be very fast. Within a minimum possible time, you should solve the questions. What will happen, na? What will happen if the simple question asked, if you take more time, then you are wasting, actually you are wasting the time. Why? Because if you save some time while solving the easy questions, the amount of time you saved while solving the easy question will be utilized in the tougher questions, while solving the tough questions, right? Remember this thing. Remember this thing. When there is a simple question, try to solve that question in a minimum possible time. Why I am saying like this? Because if you save some time in solving a simple question, then the saved amount of time will be utilized in solving the tough questions. So you have to manage the time while giving the examination. You have to manage your time properly. It's all about the management of a time. Every serious student, every serious aspirant is going for the examination with the same objective, to score the maximum possible mark. But they are getting the different marks. Why? Because they are not able to manage the time properly while giving the examination. Definitely there will be a pressure on them. Okay, that's obvious. But you have to manage your time, manage yourself in a best possible way. So always try to solve the simple question as soon as possible in the minimum possible time. And the saved amount of time we can invest in the tough question, right? Abhishek, you are getting the answer 2. Absolutely correct. Absolutely correct. You are getting this exactly correct answer, right? Very good. Very good, Abhishek. The simple question only. Again, the simple question. If you know the basic fundamentals, your fundamentals are clear, crystal clear, then definitely any question will be simple for you only. Any question will be simple for you. No matter whatever has been asked from this particular question. Slide crank mechanism, Whitworth quick return motion mechanism, anything can be asked, but you know the basics, then you can answer any question. You can answer any question, right? 2 is the correct answer. Race, Abhishek, 2 is the correct answer. 2 is the correct answer. The simple question only. The simple question only. So, whatever we have discussed in this session, first, the slide crank mechanism, second, the Whitworth quick return motion mechanism. What is special about this mechanism? We have discussed this mechanism with the animation part. Again, if you have any doubt, just go back and again watch the animation. Because only animation help you in visualizing the concept of mechanism only. It is the greatest tool to just visualize the animation. Okay, it's all about the visualization in your mind while solving any mechanism question. I hope this session is very useful for you. Definitely, we will be getting some more important things from this session, and definitely it will help you in your upcoming GATE examination. Thank you, Abhishek. Thank you so much. Now we will be end this session, but tomorrow we will be having a session from the same subject, theory of machine, from the the gate train topic. Again, one of the most important topic from the theory of machine, the gate train, and we will be solving the gate train from 2 methods, the tabular method and the relative velocity method. 2 methods. From 2 methods we will be solving. We will be solving from both the methods. The gate train, again, one of the most important topics. That's why I have selected 2 most important topics for the theory of machine. First, the slider crank mechanism. Second, the gate train. And you already know from the gate train many questions has been asked. So tomorrow session, be prepared for the tomorrow session. We will be having a superb discussion on the gate train. We will be having just a quick discussion about various gate train, but more important focus will be on the epicyclic gate train. The epicyclic gate train is one of the most important topic in the theory of machine part as far as gate is concerned, right? So today from the today's session, I will end here only. But for the tomorrow session, meet me live at 8 PM only. Okay. Till then, thank you so much and all the best for your GATE examination. Thank you so much. you.